Hello everyone, I'm going to explain today what is the coriolis force. So first, we need to understand a concept called the conservation of angular momentum, which describes objects that are spinning around. Momentum is defined as mass times velocity times radius. And if no external force is applied to the object, the momentum will stay the same. This is illustrated by this picture of a ballerina. When her arms are out, she has a big radius. But then as she brings her arms in, her radius decreases. No external force has been applied, so her velocity must increase in order for her momentum to stay the same. At a global scale, the Earth is spinning around with a certain angular velocity called omega. Different parts of the Earth have different radiuses. For example, near the north and the south, you have a small radius. And at the equator, you have a big radius. Therefore, objects that are near the north are moving slower, and objects that are near the equator are moving faster. So, what if someone near the equator throws an object to someone at the north? Well, the person near the equator has more angular velocity, or angular momentum, than the person near the north. Therefore, as they throw the object, it won't go straight to the person, but it will increase in speed because the radius is decreasing in order to conserve angular momentum. So the trajectory will look something like this. Similarly, if someone in the north is throwing something toward the south, it will need to decrease in angular momentum in order to conserve the angular momentum. Therefore, the trajectory will again curve toward the right, but in the opposite direction. In the south, trajectories curve toward the left because it needs to conserve angular momentum, so it will need to decrease velocity. And someone from the equator throwing something toward the south would make the object curve toward the left again in order to increase velocity and conserve angular momentum. Now, what about objects thrown east and west along lines of constant latitude? Well, this requires that we understand centrifugal force. So if you have ridden around on a merry-go-round, you have experienced this force. As the merry-go-round spins faster and faster, you feel more inclined to fly off the merry-go-round. On the Earth, as depicted by this elliptical slice, because the Earth is an ellipse, not a sphere, there are several forces acting on a body on the surface of the Earth. First, gravity is pulling you toward the center of the Earth. And second, as you stand on the Earth, because of Newton's laws of forces having reactions, you have a reaction pushing up against you from the Earth. What do you feel when you stand on the Earth? And also, because the Earth is spinning round and round, you have a centrifugal force tending to make you fly off the Earth. As the object is spinning faster, it has more centrifugal force and will tend to be pulled toward the equator. As the object is spinning slower, it will have less centrifugal force and will tend to be pulled toward the North Pole. We can draw that on this picture of the globe. As an object is moving from west to east, it will increase in velocity and have an increase in centrifugal force. So it will be pulled toward the right, toward the equator. In the South Pole, as an object moves from west to east, it will be pulled toward the left, toward the equator. And as an object is thrown from east to west in the North Pole, it will have a decrease in angular velocity and a decrease in centrifugal force, which will pull it toward the North Pole. And similarly, in the Southern Hemisphere, an object thrown from east to west will lose angular velocity, decrease in centrifugal force, and will be pulled toward the left, toward the South Pole, like so. So, based on our discussions of east to west motion and north to south motion, an object that is thrown in the northern hemisphere will move to the right, and in the southern hemisphere it will be pulled toward the left. This response of objects moving on a spinning Earth is called the coriolis force.